Hi, I'm Emma, and welcome to my channel. In the last video, we learned ways to control the flow of our code. In this video, we're going to learn how we can bundle all of these elements up into classes and objects. If you remember back to the Hello World video, the very first thing I asked you to do was to make a class, even though I didn't really explain what that was at the time. This is because classes are so important to the Java programming language that pretty much all code must exist inside of one. In other languages like Python or JavaScript, classes are optional, but not Java. Everything starts with a class. So what exactly are classes? Well, the short answer is that classes are like blueprints, and they're used to create objects. Simple, right? I mean, everyone knows what objects are, right? Okay, I suppose that real objects aren't quite the same as objects in a computer's memory. Objects and classes are very tightly connected, but let's start with objects first. An object, at a very basic level, has two aspects to it: what it is or has, and what it does. First up is what it is. Another way of saying this is that objects have properties. These properties can either be information about it or other objects. Take the family pet, for example. The most common pets are dogs and cats. A dog has a variety of properties. It has a name, it has an age, has a fur color. These properties contain data about it. However, these properties can also refer to other objects. Maybe it has a favorite toy or a food dish. A class acts as a template or blueprint for creating an object, but it's important to understand that it's not the object itself. After it's created, the properties of one object can be different than other objects of the same class. Let's use an example. I'm going to create a dog class. Java enforces a one top-level class per file rule, so I need to make a dog.java file. Normally I would let my editor help me with this, but we'll do it from scratch so we can see all the necessary parts. The first line of any Java file describes the package that it lives in. Classes have packages to keep them organized and avoid name collisions. So in this case, we're going to put our dog class in package org.firstinspires.ftc.teamcode. This means that if there are any other classes that are also named dog, they can coexist, because this class's full name is really org.firstinspires.ftc.teamcode.dog. Most of the time, this package only comes into play in the import section, and we refer to the class by its short name in the code where it's used. After the package line, start with the public keyword. This tells Java that classes outside of this package are allowed to see and use this class. Next comes the class keyword. There are a few other keywords that can go here, but we'll leave that to the advanced video series. And then we put the name of our class, dog. By convention, classes start with an uppercase letter. You should follow this convention too, otherwise you might end up confusing your teammates. And finally, we add a curly bracket block. This is really important. All of the code for this class has to appear between these two curly brackets. Later on, we'll add more code that also has curly brackets inside here, but make sure that every opening curly bracket has a matching closing bracket. You're now looking at a completely valid definition of a class that, once again, doesn't do much. Let's give it some properties. Technically, what we're going to create are really called fields. A field is a variable that stores data for an object. They don't become properties until other objects can see them. For our purposes right now, they're basically the same thing. Inside the class's curly brackets, add these variables, aka fields: string name, int age, string breed, and string fur color. These fields will store the data about each individual dog object. But remember our video about variables. If we don't initialize them ourselves, they'll be empty, and in the case of the strings, could crash the program if we access them while they're still null. One way we could do this is to initialize them all to default values right on the line, like this. But doing it like this means that every dog object that is created will start out with these values, and then we would need to change them to what we want. Sometimes the default values might be okay, but if not, it would be bad if we forgot to change them. There's a better way to initialize these fields. It's called a constructor because, well, it helps construct objects. But we need to take a detour before we talk about what a constructor is, because it's a special case of something called a method, and we haven't talked about those yet. So we'll come back to put some data in these fields in just a bit, but first we need to talk about that other aspect of objects we mentioned, what they do. See, objects in Java are more than just containers for data. They can perform operations using code that is associated with them. In the programming world, when we create a chunk of reusable code, it can have a couple different names. Subroutine, function, procedure. If you're coming from First LEGO League, it might have been called a MyBlock. It's called a method when it's associated with a type of object. A lot of these terms are used somewhat interchangeably. A function or method has these parts. It has a name, input parameters, and a return type. Input parameters, also called arguments, are values that are available when the chunk of code is running. When the method is finished running, the return type describes what kind of value will be sent back to the place where the method was called. In Java, the type of value that will be returned comes first. If, for example, the method is supposed to do a calculation and return a number, then the return type might be an int. If the method checks a condition, it might return a boolean, or whatever makes sense for the situation. The really important thing to note is that it can only return one value. So if you need to return more than one thing, you'll need to figure out how to package the values up into a structure that can be returned. For example, let's say that you had a method that calculated the coordinates of where your robot is on the field. You might need to return both an x and a y value. If the return type is just a double, then you would only be able to return x or y. But if you use a point object that has x and y fields, you can return that single object. Whatever type of value you choose to return, you have to tell Java which value to return from inside the method. You can do this with the return keyword. Most of the time, this will look like return followed by the name of a variable, but you can use any expression that evaluates to a value. There's another special keyword that can also be used as the return type. It's the word void. It means that the method isn't planning on returning any value, it's going to return nothing. Methods that return void are more useful for the side effects that happen when they run. In our tank drive example, when we called the setPower method on the motors, we didn't really care what the method returned. We cared more that the motor started running. The next thing in a method definition is the name of the method. You can name this almost anything you want, but the convention is to start a method name with a lowercase letter and use camel case for the rest of the words. My advice is to start methods with verbs that indicate what the method is going to do. Naming a method raise arm rather than set arm level is a little more clear that the robot is going to move if you call that method. After the name of the method comes a pair of parentheses. Inside the parentheses, you can optionally declare any input parameters that the method will need to do its job. Parameters look like variable declarations, where the type comes first and then the name. You separate parameters with commas. It's not mandatory for a method to have parameters if it can get the input it needs from some other place. Look at the init and loop methods in your op mode. No parameters, just an empty pair of parentheses. On the other hand, sometimes parameters are very necessary. Look at the setPower method. It has one parameter, power, which is a double. The method definition looks like this. The last thing you need to define your own method is a curly bracket block that will hold all of the code that the method will run when it's called. Now that we know what a method is, you might be asking, when do I use them? If you find that you're tempted to copy and paste the same code in two different spots, that's probably a good time to make a method. When I was in FTC, our robot class had methods for go straight this many inches, turn left this many degrees, etc. Okay, so now that we covered methods a bit, what about that weird constructor thingy we talked about earlier? Well, a constructor looks a lot like a regular method, but it has two important differences. The first difference is that you don't specify any return type, not even void. In a sense, it is actually returning something, a newly constructed object, but since you can't really change it to anything else, there's no sense in typing it in. The second important difference is that the method name must be exactly the same as the class. So if you create a dog class, then the constructor must also be named dog. Same capitalization and everything. Now we can go back and make a constructor that sets up a dog object. We can take off all of the default values first. Below the fields, we'll start with the public keyword so that other classes can see the constructor. Now we'll skip the return type and type in dog, a pair of parentheses followed by a block. This is the most basic constructor you can make. In fact, if you don't make any constructors at all, the compiler just automatically includes one for you. But with no parameters, it's not particularly useful. Let's fix that. In between the parentheses, let's add some parameters. Because coming up with names is hard, we're going to use the exact same names as our fields. So string name, comma, int age, comma, string breed, comma, string fur color. However, by doing this, we actually created a problem for ourselves. We need a way to take the value in the parameter called name and store it in the field called name. If we just type in name equals name, it's not going to do what we expect. The name parameter becomes something called a local variable inside the code block. Our equals statement will just take the value inside the local name and then store it back into the same variable. To solve this problem, we're going to make use of a hidden variable, one that exists in every class's method. The variable is called this, and it always contains a reference to the object that the method is associated with. If we prefix the first name and write this.name, now it knows that the name variable is the one attached to this object. Let's go ahead and add statements for the rest of the fields. Now our dog class is ready to use. But remember, the dog class is just a blueprint for making objects. How do we use the blueprint? The answer to that is the new keyword. Let's examine what the code would look like to make two individual dog objects. For the first object, start with a regular variable declaration, so the object type of dog and then the variable name. After the equals sign, use the new keyword and then tell it what class to use, and then follow it with a pair of parentheses. What we're doing here is calling the constructor to make a new object. Inside the parentheses, we'll give the constructor 4 values, also called arguments. Even though many people use the words interchangeably, parameters are what we call the input variables for a method, but when we call the method and give it some values, these are called arguments. For our first object, we'll write a string in double quotes, Bluey, and then age 6, breed blue heeler, and finally fur color, blue and tan. For our second object, we'll do the same thing, but change the variable name and then use different arguments, bingo, for, blue heeler again, and orange and cream. Notice that both objects use the dog class that defines what properties they have, but the actual values in the objects are different. If I were to update the objects and add 1 to their ages, like this, Bluey's age would now be 7 and Bingo's age would be 5. But why did I make a dog class instead of something more robot-y? Well, there's one last big concept that we saw in our tank drive code, and using an animal like a dog makes it a little easier to relate to. It's called class inheritance. And we saw it in action when we used the keyword extends and then followed it with op mode. What that bit of code meant is that there is a class out there called op mode, and we want to inherit stuff from it. In other words, everything that it has, we want too, plus all of the things we're going to add or possibly do differently. Or, as we wrote, our tank drive extends the op mode class. To think about this, let's imagine that there is a cat class as well. While we're building the cat class, we might notice that there are some common properties that both cats and dogs share. In fact, it seems that all of them apply to both. But instead of copying and pasting them all into the cat class, we could instead make a pet class and move all of the properties there. So anything that is a pet has a name, an age, and so on. If both dog and cat extend pet, then they both have these properties. But despite what our digital model says, real dogs and cats aren't the same. For example, they behave differently. To illustrate this with a slightly silly example, let's add a play method to our pet class so that both subclasses inherited it. But we really don't know what to put in there because, well, almost all pets play, they do it in different ways. So what we can do is override the play method in the cat and dog classes. For a cat, the play method might look like this, while a dog might look something like this. When you call the play method, different things will happen if the object is a dog versus a cat. And now we can finally explain why we have those @override annotations on the init and loop methods. The class we're overriding, also called the superclass, op mode, has these methods already, but they don't do anything. Sort of like pet play didn't do anything. It's up to you to extend the op mode class and add actual code to make the robot do something. Obviously, there's lots more to know about Java, but I think you have enough to put it all together and make a new op mode. Hopefully, this time you'll understand more of the code that you're typing in. In the next video, we're going to add a new op mode with a different way of controlling our pushbot, called Arcade Drive. See you there!